Lesson 10.3, combinations. For combinations, order does not matter. So here's an example where we can see order does not matter. You have a club with 30 members. You are to select 3 members to represent your group in a school assembly. How many different selections can you make? So here we have our pile of our 30 members, and this time we are selecting 3 representatives for the school assembly. We have 3 people. So we do not want to use these people, and if I next time give a slightly different order, have this count as a second option because these are still the same 3 people. The order in which I select them doesn't matter because we still have the same 3 people going to the assembly. The calculation for this process is called combination. This is when you are finding the possible outcomes and order doesn't matter. The equation for combination is n factorial over r factorial times n minus r factorial. N and r mean the same things as they did whenever we were doing permutations. N is our total number of things or objects. R is the number of objects or things that are going to be picked. So in our example, since order does not matter, we have a combination. We had 30 members and we have 3 places. And at the bottom, let's jump down to the bottom of the page and let's go ahead and write our notes for calculating. It's going to be very similar to what we did on permutations. We're going to go math button. We're going to arrow to the right and choose probability. Then we're going to go down to NCR and we're going to press enter. We're going to edit the N and the R so that we have the numbers that we need in those places. By hand, if we use the formula, we would start off with 30 factorial over 3 factorial, and then we have 30 minus 3 factorial, which would simplify to, remember 30 factorial is 30 times 29 times 28, and I'll write that out in a second. 3 factorial, and then 27 factorial. 30 minus 3 is where I got the 27. 30 factorial would be 30 times 29 times 28 times 27 times 26 and so on until we get 3 times 2 times 1. 3 factorial, 3 times 2 times 1. 27 factorial would be 27 times 26 times 25 and so on until we get 3 times 2 times 1. So just like we did on the previous example with permutations, all of these 27s down to 1 will cancel out with the denominator 27s all the way down to times 1. We could possibly simplify in here, but you could also just type that in and get your answer. So we can do that on the calculator by either using the factorial button that we saw, or you can type it out using the numbers if you simplify it by hand, or we can use the calculator shortcut of NCR. So those are the 3 ways that you could figure out the answer using your calculator. For our example in the introduction, we're going to go math. We're going to arrow over to the right till we get to probability again, and this time we're going to go to a combination because the order doesn't matter. And we are going to select 3, and we're going to edit that to where we have 30 and 3, and we have 4,060. If you wanted to type it out by hand, you could have also done 30 times 29 times 28, and then on the bottom we had 3 times 2 times 1, and that will also get you the same answer. If you wanted to type it in using your formula and the exclamation marks, remember those: math, probability, and you can type it in using your exclamation mark. The final answer for our example, where we are selecting 3 members to represent our group at the school assembly, was 4,060. Final answer. Example 1. Anicia's mom told her she could pick 3 friends to take on a family trip with them. How many possible choices does she have when choosing between her 7 closest friends? So it doesn't matter when she makes her list what order she picks, because in the end she's going to take the 3 people and they all just go as a group. So we have our 3 places and we have 7 friends total. Because order does not matter, we use a combination. 7 is our total number and we want 3 places filled. So we are welcome to use our calculator at this point. I'm going to write the formula by hand so we can remember 7 factorial over 3 factorial times 7 minus 3 factorial. If you simplify that a little bit, it would be 7 factorial over 3 factorial times 4 factorial. And you can do that by hand if you would like, or you can go to your calculator and you can type it in. When we get on our calculator, we're going to choose math. We're going to arrow over to the right to choose probability. We're going to choose combination, the one with the C, because order does not matter. We're just picking 3 friends. 7 friends total, but I only have 3 places that we can fit in the car. And there we have 35 as our final answer. There are 35 different ways that she can choose between her 7 closest friends and take 3. 35 is your final answer. When calculating example 2, we can type this straight into the calculator and we already have our notes. If you wanted to do the formula by hand, you are welcome to. You can see the notes above, but we're going to go type this straight into the calculator and also B. Example A, math. Arrow over to the right to probability, and we're going to choose option 3. And we have 10 things total, and we have 3 spaces to fill. For example B, math, arrow to the right for probability, arrow down to combination to get that C in the middle. We have 5 items total, and we have 5 places to fill them in, and order will not matter. Because the order doesn't matter, no matter how you arrange them, if you only have 5 items that go into 5 places, it doesn't matter the order, so you only have one way that you can fill those. Filling in our answers on our sheet, we have 120, and we also have 1 for that last question. These are your final answers for example 2.